Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE Maths? Well, if you are, please continue to watch, as in this session, we look how to solve and attack problems that incorporate advanced work using Surds. Now, as we always say, as we look to tackle these more challenging topics, we will inevitably be calling upon your previous understanding and prior knowledge. This session's absolutely no different, but more specifically, in this session, we will be calling upon your ability and knowledge of expanding brackets, multiplying fractions, factorising to a degree, but then also simplifying fractions when it comes to identifying our final answers. But without further ado, we're going to make a start. So please continue to watch if you are somebody looking to achieve one of the highest grades possible in GCSE Maths. Now, in question 1, we are being asked to simplify fully the fraction 3 all over 2 plus root 5. Now, straight away, hopefully you can see we have a surd in the denominator. We have the square root of 5. The way we eliminate, rationalise being the key word, the denominator, and rationalisation, remember, means to remove any surds from the denominator, is to multiply by the conjugate over itself. Now, the conjugate of 2 plus root 5 is 2 minus root 5. But please note, I did say over itself. If we think back to when we've looked at surds previously, when we rationalise a surd, we're not actually able to change the value of the surd itself. We're looking to change how it's written. Let me get my pen sorted. So it'll be multiplied by 2 minus root 5 over 2 minus root 5. And this is where we're going to call upon your knowledge of multiplying fractions. So our numerator will be 3 lots of 2 minus root 5. And at this stage, I'm not going to expand. Our denominator, 2 times 2 is 4. 2 times minus root 5 will be minus 2 root 5. Root 5 times 2 will be plus 2 root 5. And then root 5 times negative root 5 is negative root 25. For those of you who are more confident with surds, you may actually have written minus 5 at the end in one go. That's absolutely fine. So then let's simplify things. I'm still going to have 3 open brackets 2 minus root 5 as my numerator. But my denominator, and I always do this using a different coloured pen, I can straight away cancel out minus 2 root 5, add 2 root 5. And so my denominator will become 4 minus 5. At this stage, I am going to make the decision to expand the brackets in my numerator. So that will give me 6 minus 3 root 5 all over minus 1. And that then simplifies, because we're dividing through by negative 1, to 3 root 5 subtract 6. Now, straight away you can see this is far more advanced work on surds than perhaps we've covered in other videos. So please, if you do need extra help, be sure to check out some of the other videos on this topic. Let's look at question 2. So it looks similar, but this time we have 2 surds, if you like, 2 square root symbols in the denominator. But the way we simplify, the way we rationalise, is we multiply by the conjugate, but remember the conjugate over itself. In other words, we must multiply the numerator and denominator by the conjugate, because the reason being, whilst we're looking to remove any square roots, surds in the denominator, we're not allowed to change the size of our starting value. And the only way we can do that is multiplying by 1. So I like routine for that clarity. I'm not going to expand my brackets in the numerator initially. So I will simply write 5 open brackets, root 2 minus root 3 close brackets. In my denominator, root 2 times root 2 gives me root 4. Some of you might write 2 straight away, that's fine. Minus root 6 plus root 6 minus root 9. I can take my different coloured pen because my minus root 6 plus root 6 straight away cancels. And that will leave me my numerator as 5 open brackets, root 2 minus root 3 close brackets, nothing's changed there, all over square root of 4 is 2, the square root of 9 is 3. And it's at this stage I will expand my brackets, so that gives me 5 root 2 subtract 5 root 3 all over minus 1. Because we're dividing through by minus 1, this numerator, if you like, or my overall answer will simplify to 5 root 3 subtract 5 root 2. Our prior knowledge of dividing through by negative 1 being called upon here. Question 3. Simplify. So you'll note the word rationalise hasn't actually been used in any of these questions, and that's where the conceptual understanding, the higher tier thinking, is really being called into question. Now, the first thing I'm going to do is simplify this initial expression. Let's keep things nice and neat and nice and consistent. 1 over root 2 plus root 2. Well, that's the same as writing 1 over 2 root 2. To simplify, to rationalise, I multiply by the conjugate over itself. So 2 root 2 over 2 root 2. I know it's a bit of a hack, but you'll note there's no symbol here for me to flip. So it is the same, the conjugate over itself. What will that give me? 1 times 2 root 2 is 2 root 2. Then my denominator, 2 times 2 is 4. Root 2 times root 2 is root 4. That gives me 2 root 2 over 8. Which leaves me with root 2 over 4. I'll just do a little bit of work at the side here, and that's because 2/8 is equivalent to 1/4. Again, simplifying fractions being called upon. Question 4. A much more complex looking problem, but essentially this calls into question your ability to add and subtract fractions. Most notably, when we add and subtract fractions, what do we need? We need a common denominator. I'm just going to, no, I'll carry on here actually. So, if I draw my fraction line ready, my common denominator I will achieve by multiplying the two denominators together. So that'll be root 5 plus 2 multiplied by root 5 minus 2. If you like, my left-hand numerator will be 3, open bracket, root 5 minus 2, and we're subtracting. My right-hand numerator will be generated by 3, open bracket, root 5 plus 2. I'm just going to move over here so I've got a little more space. I'm now going to start expanding some brackets. So I'll start with my numerator. I will have 3 root 5 minus 6 minus 3 root 5 minus 6. In my denominator, I will have root 25 minus 2 root 5 plus 2 root 5 minus 4. Before I start doing any simplifying, I'm just going to put my fraction line in. But I can start simplifying straight away. 3 root 5 subtract 3 root 5 will cancel. Minus 2 root 5 plus 2 root 5 in the denominator will also cancel. So what am I left with? On the numerator, negative 6 subtract 6, negative 12. In my denominator, the square root of 25 is 5. 5 take away 4 is 1. So I'm actually left with negative 12 divide 1, which is quite simply negative 12. I'll just remind people, the level of difficulty today is certainly higher tier. We're certainly looking at the very highest grades possible. So if we have touched upon any knowledge or understanding of surds, fractions, where you might need a little bit of extra help, please be sure to check in with our other videos. But for now, the very best of luck in your quest to achieve one of the highest grades possible in GCSE Maths. And thank you for watching.